All right, so I think I'm recording. We're looking at our review problems for college algebra first semester. Here they've given us equations, y in terms of x, and they're asking us to state the domain. And we know that anytime we have an equation, that the domain is always the set of all real numbers, excluding any values that cause division by zero, and excluding any values that cause us to take the square root or even root of a negative number. I do not have any variables in a denominator, so I don't have to worry about that. But I am concerned that there might be some value of x that 3x minus 6 is negative. I need it to be 0 or positive. So let's solve this inequality for x. 3x, if we add 6 to both sides, has to be greater than or equal to 6. You have to be bigger than or equal to 6 because otherwise you'd be negative. So divide both sides by positive 3, and 6 divided by 3 is 2. So on a number line, here's 0, 1, 2, 3, 4. And if you pick values that are bigger than 2, I guarantee you when you plug them into this radical, that first number is going to be so much bigger than 6 that when you take 6 away, it'll still be positive. But if you plug in a number like 0 or 1, you plug in 0, and you got 3 times 0, which is 0, and 0 minus 6 is negative, and we can't take the square root of negative 6 in the set of real numbers. So here's our answer. We need to describe that answer using interval notation or set builder notation. We've got that the domain of this is from 2 to positive infinity. If you're writing that in set builder notation, it's a set of x, such that x is the set of real numbers, such that x is greater than or equal to 2. All right, so let's go ahead. I think there's another part. Let's go ahead and do all the parts, yeah. So this is still problem 13, but here, if I'm given an equation and asked to find the domain is a set of all real numbers, excluding any values that cause division by 0 and excluding any values that cause us to take the square root of a negative number. I don't have any square roots or even roots in this problem, but I do have variables in the denominator. I'm concerned, what if there's some value of x that when you plug it into this equation, x squared minus 7x minus 18, you get 0. So let's solve this equation and then avoid those values in the domain. This is a quadratic, completing the square and quadratic formula guaranteed to work, but I can easily look and see that this can be factored to x minus 9 times x plus 2. I have a zero product rule that says if you're multiplying two numbers together and you get 0, either one or both of those factors have to be 0. If x minus 9 is equal to 0, it's obvious by inspection that 9 minus 9 is 0. If x plus 2 is equal to 0, it's obvious by inspection that negative 2 plus a positive 2 is 0. So if we plug in, if we let x equal 9, 9 minus 5 is 4, but we're going to have 4 divided by 0. We have to throw that out of the domain. If we plug in negative 2 minus 5 is negative 7, but it's going to be divided by 0. We've got to throw that out of the domain. These were the only two solutions to this equation in the denominator that made it equal to 0. So let's draw a number line real quick to help me write the answer in interval notation. Negative 2, negative numbers are to the left of positive numbers. I'm going to exclude negative 2 and exclude positive 9. But all of these other numbers, they did not cause division by 0. So they're in the domain. So the domain of this is from negative infinity to negative 2. I'm excluding that, so I need a union. And then I go negative 2 to positive 9. I don't use brackets whenever I have hollow dots. And I never use a bracket around my infinity symbols. So here's my answer using interval notation. Set builder notation, if it's a set of all x such that x is an element of the set of real numbers, the left interval can be described values of x that's strictly less than negative 2, in union with, well, the middle part can be described as values of x that are between negative 2 and positive 9, and the right part values of x that are bigger than 9. All right, so I hope that, let's do part C. uh, we've got the perfect storm going on. Remember that the domain given an equation is the set of all real numbers excluding any values that cause division by zero and excluding any values that cause us to take the square root of a negative number. I have a variable in a denominator, so I want to make sure that 1 minus x is never equal to 0. I have to make sure that x is never equal to 1. Well, at the same time, I need 1 minus x to be a positive value. If I make it greater than or equal to 0, then that'll avoid the negative. When I say make it positive, I really should have said make it non-negative, 0 or positive. But we've already determined that it can't be 0, so I need to solve this inequality when it's strictly greater than 0. So I've got negative x is greater than negative 1 if I subtract negative 1. If I divide both sides by negative 1, I have to change the direction of the inequality. So as long as I pick values of x that are strictly less than 1, then down here, this radicand underneath this radical is always going to be positive. It'll never be 0, it'll never be negative if I make sure that values of x are strictly less than 1. So if I draw a real quick number line, just to give me a picture, values of x that are less than 1 are to the left of 1. Values like 2, 1 minus 2 was a negative number. I had to avoid that. 1 minus 1 was 0 in the denominator. I had to avoid that. But numbers like 0, 1 minus 0 is 1. I can take the square root of 1, so I'm good. So I need to describe this set of numbers, that this interval, using interval notation. So the domain, the left arrow is shaded from negative infinity up to positive 1. And there's my domain. If it's in set builder notation, that same domain is the set of x, such that x is an element of the set of real numbers and x is strictly less than 1. All right, I think that's it. Yeah, so I hope that helps, and I'll talk to you later.